because first I start, then I hand over to the Marcin, and the last part will be presented by Deluca.
Okay. So please, guys, try to stick to the times we've got because we're already quite late. Okay.
Okay. Thank you.
Okay. So Jacek, you can go.
Okay. So first we will present our packages. I mean packages we've been created together, and I mean Marcin and I, and then Luca will present his own package about the BMA. We'll focus on the first three packages. I mean, let's say the canonical BMA, Bayesian, which is a short name for the Bayesian averaging of classical estimates, and the package we are currently working on, which is unreleased. It is the BMA for the ADL or orthogonally distributed lag models. And some basic information where we can find the packages, because two of them are available on the Gretl server, so it's quite easy to reach them. Because if you have a Gretl application, you can find it, you can download it inside the Gretl. So it's just quite simple thing, and one of the very fine feature, Gretl feature. And first package is just let's say the copy of functionalities available in our packages, and say it's like the canonical BMA, and we have the same prior structure as, for example, in Fernandez Leistel and 2001, and as well as the second paper. And we also focused on the MC cube sampling algorithm. And quite good thing is that this is the only package which provides the GUI. So you don't need to be familiar with the coding. You don't need to know R or whatever. 477. You just can open the Gretl and find this feature and just run the BMA code inside the Gretl. And as you can see, here we have a standard features for the every Bayesian model averaging. So we have to define dependent variable, list of independent variables, different prior models, as well as prior average model size, and also the information about the initial models. This is the penalty value, so we can shrink initial model, or we can just make this initial model as big as possible. And also information about the output. So for example, Tongue models, G prior, two type of jointness analysis, as well as number of sample forecast, number of replications, percentage of Bernoulli draw, and verbosity. Verbosity is a dummy variable, and we can set it to 1 or 2, and if we set it on 2, we get more detailed information about the algorithm and optimization and so on. So this is a quick summary of our GUI window. So just common typical things related to the BMA. And this is verbosity, as I mentioned, for example, for BC equals 2, the more detailed description analysis of the provided initial model, speed of convergence, estimation results, and top rank models. Yes, and this is the first example, and the second one is the BMA autoregressive distributed track model. It's also quite new thing for us. I mean, the goal is to be in line with Bayesian methodology and to proceed with the models where we can put priors which impose tensionality restrictions on parameters, and idea is to select the models between different legs for the ADL class, and quite simple summary of the posterior density. So we have a posterior density, and we have also the some kind of integration function to cut off non-stationarity regions, and also we have a normalizing constant, which is quite a little bit different from the standard one, because we have a stationary autoregressive process, and also some simple summary of iterations in the MC cube. So we have 2 steps of Monte Carlo iterations. The first one is general, I mean the MC cube, and the second one is we have to draw random variables from the posterior distribution for the gamma from the gamma distribution. I mean for the variance, and then we can switch to autoregressive parameters and then draw conditionally from the normal distribution. And after that, we can accept some draws which obey the stationarity rules, and then we can calculate normalizing function, and then just accept model and as it stands in MC cube algorithm. And here's the BME Go window, and so we can also set the maximum number of legs for t, I mean for dependent variable. Also, we can using the Gretl features or functionalities, we can also set up maximum number of legged explanatory variables, and as well we can just put constant in the model, or we just can calculate without this constant. Some similar things related to the BMA, so the prior model average size, significance level for the starting models, for the static model, and as well the jointness and benchmark priors. And we can set up 2 iterations in the Monte Carlo loop, one for the MC cube, and the second one to draw the values from the draw the samples from the posterior distribution for the autoregressive parameters, and some summary. So I will skip this slide. The only thing is we can also calculate it in 2 ways to impose tensionality restrictions and just to skip this restrictions. And the last one is BAEC. So this is not a pure Bayesian approach, because it is approach based on the RLC estimates, and we also we also conduct with this method to, for example, to compare classical estimates with BMA, so we can compare, for example, apple to apples, and then where we can see some advantages of using, for example, model averaging comparing to the other algorithms, for example, autometrics. And that's almost all from my side. Just only a reminder how we calculate posterior probability. And as Professor Marcin mentioned, this is approximation based on the Schwarz criterion, BIC. So the method is quite straightforward and quite easy to implement. In my opinion, this method works like, let's say, skeleton key. Yes, you can almost open everything if you have a BIC approximation. Yes, and you just put everything in MC cube and just mix the models. Quite surprisingly, and Maciej will also show this. This method works quite well, and sometimes quite vague. Improper price gives us quite good estimates, and even sometimes quite good forecast. So this is what we found. It was very surprising for us, but that this method works better than we expected. And so that's all from my side, and